Today we are going to discuss about effect of structure on reactivity of compound. Effect of structure on reactivity of compound. Effect of structure on reactivity of compound is an important topic in pharmaceutical chemistry 1 organic, and it actually shows us that how the structure can affect the reactivity. By knowing these effects, you will be able to predict the reaction shown by particular molecular structures. So there are various effects shown by any molecule, but here we are talking about some of the basic effects that can affect the reactivity of any molecular structures. So number one is inductive effect. Number two is mesomeric effect, and number three is electromeric effect. These are the three types of effect that can be present in any molecular structure. And they influence the reactivity. So the first one is inductive effect. Let's discuss what is inductive effect. Inductive is the polarity produced by molecule due to the presence of high electronegative group within a molecular structure. Remember that it is related to sigma bond. For example, we take a carbon chain. Let's suppose it is comprised of 5 carbon atoms. Here we have carbon number 1, carbon number 2, 3, 4 and 5. It can be the structure of pentyl group, and we attach here with the first carbon a chlorine group. Now we know that this chlorine is highly electronegative, and it will try to pull these sigma electrons. And the effect that is produced by this chlorine group will be the attraction of this sigma bond towards the chlorine atom. Thus, there appear charges that chlorine will acquire a partial negative charge and carbon will acquire a partial positive charge. Now the question is, will the chlorine atom attract these sigma electron that are bonding pairs? The answer is yes. We have understand that there where there is a bond, there are two electrons present. Now what chlorine will do is it will attract these towards itself. Thus there appear partial charges which are represented by partial negative and partial positive. Now another thing, how will you represent this effect? Of course, it will be represented by the charges that are present, plus we will draw small arrows within this bond. Let's suppose this carbon atom is directly attached with chlorine, so we will add three arrows that will indicate more attraction, but this bond here we will draw two arrows, slightly less attraction, and here we can draw only one arrow. Remember that inductive effect is transmitted along the chain of the carbon atom. So, the effect of this chlorine will influence this bonding pairs. It will also affect this bonded pairs and definitely this bonded pairs. But the effect, inductive effect, is negligible after fourth carbon. There are two types of inductive effect. Number one is plus inductive effect, and number two is negative inductive effect. Let's discuss plus inductive effect first. If the electron donating group is attached with carbon chain, then it will produce effect which will be called as plus I effect or plus inductive effect. For example, we have a carbon chain of 5 carbon atoms, and we attach it with any alkyl group. Let's suppose it is secondary methyl group. Now these methyl groups are actually electron donors, so they will donate the electron and will increase the electron density within the carbon chain. Here we have C1, C2, C3, C4 and C5. So what are those electron donating groups? Remember that it can be tertiary methyl group, which is represented by 3 naught, methyl, which will have more inductive effect than secondary methyl group, which will have more effect than primary methyl group, or simple methyl group. So whenever these groups are present within a molecular structure of carbon atom, they will actually donate their electron pairs towards the chain, and thus they will increase the electron density. Inductive effect is produced when highly electronegative atom is attached with carbon chain. For example, we have fluoro group, chloro group, bromo, iodo, nitro group, or cyano group. Carbon chain of 5 carbon atoms labeled as 1, 2, 3, 4, and 5. Now we're gonna attach it with chlorine atom. Now what we're gonna do is chlorine is highly electronegative, so it will acquire partial negative charge while there will be partial positive charge on other carbon atom, and thus it will also withdraw. It will actually withdraw electrons, try to withdraw electrons from this carbon chain, and thus the carbon chain will be partially positive. You might see this scenario in alkyl halide that we will discuss in nucleophilic substitution reaction. Inductive effect is permanent effect, which means that no matter reagent is present or not, this will remain inside the structure. So we will say that not depends upon the presence of reagent.